Oh hi, welcome to another clickbait episode of German YouTuber builds the best to himself Linux distribution live here on all of YouTube. Doing this for 25 years, if you're wondering, is this clickbait the previous recollection of history is running so well on YouTube. Let's see if we can hack YouTube, if we can repeat that, if the algorithm and the audience is so biased for that to work. Today we quickly wanted not only obviously release the best release of T2, previously known as Rock Linux, ever. For that we, as usual, have some more things to fix or improve. I was informed, I was made aware that apparently Musel, like with all our, we basically build everything, right? It's not like one glibc, one Musel, one. No, we can build everything because automation and scripting through the power and magic and hard work and sweat and tears. And I was informed by our contributing developer that, hey, some stuff broke with Musel again. Yay. Maybe only E2FS procs we will see, but obviously we need E2F procs. Anyway, we have one more thing to improve from yesterday's edition of making everything just amazing for me. And each time I find something, like I had tested, here's the previous video, right? Our AMD Phenom of our compute nodes, which this was used for business office stuff, running for nearly 13 years. Overheated, crashed, like it ran flawlessly with certainly our amazing T2 Linux as base virtualization. It ran perfect for over 12 years, and so it looks like maybe only the heat sink, the chipset overheated. That is a 785 or so AM2 plus AM3 chipset, and it always was freaking hot, the heatsink, and it was installed by Sapphire for this industrial mini IT export. With 2mm, it looks at least thick, 1.5 2 millimeter or so. Heat thermal pads between chipset, between the source and North bridge or whatever chipset stuff, and I'm surprised it conducted so well. But yeah, since I replaced that, it was also in the center rather hard where the chipset die is. I think I made a photo, I probably should load this on Instagram. Anyway, since I removed the plastic spring retained heatsink and put their normal thermal compound, thermal grizzly or something, the latest and greatest, versus spring loaded heatsink stuff, which fun fact 2 broke. Amazing. Need to order some more. Since then it is rock solid, right? So much to, if you have vintage and retro, it's not always capacitors, and otherwise since then it works. Again, hopefully, maybe. And the performance is surprisingly good. 6-core Phenom 2x6. What did happen here? Was this? Where did I even build this? Did I even build the right thing? What happened here? Was that fine? Or maybe we better clean this. Anyway, the performance is at least compiling code that is a little bit apples and oranges comparison, because code generation for x86 has vastly different performance characteristics than compiling for Spark, PowerPC, more registers, different RISC and stuff. What is going on here? What if I... Oh, my system read link, how did that happen again? Anyway, what was my point? My point was that chipset? All right, performance. So this 13-year-old 6-core from AMD builds open source faster than Sun, Niagara T4, 8 cores, 64 threads, or even Power 8 in the Tine Open Power with 10 cores and 80 threads. Absolutely crazy. And I believe similarly to the VR prototype, I got the VR char CHA1001. Let's quickly, or it was in a similar ballpark or faster than the VR, which is a VR much later. VR is 2000. Yeah, twice. So like nearly like this 6 core is faster than an 8-year later 8 core from VR. Anyway, if you have one last thing and then we continue to work. This performance index proved really amazing. I really liked it. I updated, I took some stuff, dusted some stuff out. Did I even star 5? Did I even Division 5? Yeah, Division 5, I did that. It's not that super slow compared to old stuff, right? Anyway, we need to add some runtime because build time is not as comparable. If you have any suggestions, tips, and so on for build time, we could gzip. The problem is what to do that has, so because this has practical relevance, right? Everyone is building the open sources each day, so that is directly translatable, which is why I did it, and it has a one-to-one relation with building T2 from source. Runtime is a little bit trickier to better one-to-one compare the stuff. We could just gzip some file, then some stuff has gzip accelerators, but that is what it is. Because you can only compare in one architecture, right? x86, because as I said, code generation can have quite differently algorithmic complexity, so that doesn't just compare. So we could gzip something, we could any other compressor, we could, but is that really relevant, right? For practical use? What translates the best? I mean, maybe translates the best to practical use would be rendering Firefox, rendering a website with Firefox. Then of course making a snapshot, because you cannot just render some random site that is obviously network and whatever daily changes they do to the website. So, but the problem is we don't have Firefox full architecture, so more. We could use libjpeg for JPEG. We could do some JPEG decompression. The thing is, I would like what is the best, like, comment below. Maybe I make a poll on my more main channel. What is the best, like what is the one most outstanding daily practical compute performance thing? Because even JPEG doesn't translate. Sure, we would have some number. We could also use JPEG 2000, which nobody uses, JPEG XL, which is brand new, which nobody uses. We could transcode a video, but then it's always which video, which I sometimes use some open source video, Bunny movie, whatever there was, this Blender movie ones. Maybe the easiest is just taking a T2 release and decompress and recompress it. To have, it's not the most practical. Anyway, leave in the comments below what suggestions you have. So I broke, so also contributing patches, right? And then read, what is the read line, right? Mine, I have media, nothing like hot fixing your read line. Oh darn, I generated this was from yesterday. Very clever. Tell me I don't have a. Now I have yeah, so many ISOs to choose from. You want to quickly do some code, and then you first need to fix your system because you tested your users' patches. Let's see if that builds then. And welcome everyone. Maybe it builds now. Need to check that this really works. So the one thing I actually wanted to do after nearly 10 minutes of chatting with the audience, telling my life story here on YouTube. I wanted to prove for this testing, right, because we're increasingly getting professional, building out our data center storage and just embedded open source project and stuff, and doing our other don't delay, try our amazing paperless office software today stuff. And like if I work with stuff and I find, why is our Linux distribution so great and increasingly better? Because each time I find something that's not perfect, I improve it, right? Case in point, initRD, I set it yesterday or so. I want to add more stuff, by the way, did I commit this already? Apparently, maybe I did. Let's assume up there. I've installed T2 spare machine. That is amazing. How was your experience? I hope you liked it. I hope you didn't find too many bugs. If so, which? And mk initRD. So I wanted for this thing, because the initRD, the initial RAM disk, is, if you're new to this stuff, if you always wondered why do we have this annoying initial RAM disk, spoiler, initially we didn't have an initial RAM disk. The most Linux versions were all booted without one, just the kernel, and then you booted the kernel with root equals dev HDA3 or whatever, in the good old Linux 0 and Linux 1 and Linux 2 days. And eventually the Linux kernel, spoiler alert, became too large, too many drivers. You could, like, basically the Linux kernel became too large to link all drivers in, right? Each RAID, each SATA, SCSI, InfiniBand and stuff. So modules, loadable modules, right? And if you have more loadable modules, you can't boot anymore, right? So the initial RAM disk, the main purpose, not the only, but the main purpose is to build everything modular and then have the most minimal set of stuff you would need of drivers for IDE, SATA, SCSI, Fiber Channel InfiniBand, SAS, NVMe and stuff, and only have the loadable stuff, and then more flexibility, because in the kernel booting was relatively limited. Everything you wanted to boot, you had to put into the kernel. With an initRD, you can add additional logic to the initRD, even crypto setup, right? Sure, you could code everything in the kernel, but it's more complex there, more error prone and less flexible, right? You would need to hard code everything, like this specific crypto thing and stuff. And in an initial initRD, you could program it in more easily programmable, debuggable C, C++, Rust, Go, ADA, C#, .NET, or even shell scripting, which is what we do here. And flexible and standard, right? So because if you want to do something exotic, testing and whatnot, you don't need to change kernel code. You can do this in normal user space program code. We wanted to add some more stuff. We do this with a regular expression. So what we want to include there, some file systems. We don't include everything because that would become too large. And we had historically quite nicely selected that here. But given that it is 20 megabyte compressed and whatnot, like another half a megabyte doesn't really change that too much. So let's now extend this further. And so what I wanted to include two more things. The one is, yesterday I did this testing here with this falling apart Phenom machine, which maybe only have been the chipset thermal pad. And it would actually be nice to have in testing, because that if you boot something for testing on your thumb drive, it would actually be nice if you boot your installer, which you can, like on BSD, so you can use the T2 installer as rescue system, as for testing and so on, and debugging and so on. So let's, I had checked this yesterday, so let's see, regular expressions, flists of Linux, so temp. I checked this yesterday, so we, what was it here? The temp. So luckily, if we just use that, because we don't want to include all the hundreds of hardware monitoring things, right, that we don't need. But I checked this last night already. This is because I was wondering what the heck is that even? That is a Intel chipset driver. And by the way, it would have been really cool if there would have been a standard for a decade already. That, because it's a little bit silly that for each similar CPU and chipset thing we need another driver. It would have been really forward-looking and better avoiding all those drivers if there would have been a PCI specification, think PCI 2 or whatever, like after initially PCI 1, eventually, like if in another alternate universe in history, people 20 years ago would have realized, hey, we often have temperature sensor probes things. Would have been cool if there would have been a PCI config space standard for exposing the temperatures, and you would need a bloody chipset driver and stuff. And I wonder actually if the AMD 785 or other chipsets actually have a temperature sensor, because we don't have, I don't see instantly a driver here. So we probably lock that on hardware mon temp. I'm not, which one is that here? Info drive temp. Actually, I'm not familiar with that one. Hard drive temperature monitor. Interesting. And what does it support? I would actually really appreciate if they included a little bit more description there. Or is it for NVMe drives? Driver supports reporting temperature, disk solid state drives with temperature sensors, ATA, SCT, command transport feature. If that is not supported, the driver uses smart attributes to read the drive temperature. May reset the spin down timer on some drives. This can be observed with. Yeah. I wonder, so I never used that. I thought NVMe exposes that, actually, how to even, always going down the rabbit hole. Linux drive temp, how to, if you load this, is this run for all? Actually funny that I've always wondered why we don't have a driver for that. Now it turns out we have. I wonder if that really... I know you need to bind that? Oh no. I mean, I could, what do I have on this system? On this system I only have NVMe drives, and this system probably does do nothing. I could power on, I have the Phenom on. I mean, I didn't have it on, I had it sleeping. Suspended to memory. Was it that one, or... Or did this one not? Because on some nodes I actually have. Yeah, here it was. This nonsense. Anyway, drive temp. Yeah, of course it's nothing else is named drive, but here it's named drive. Don't get something instantly, or does it bind on the SCSI class SCSI disks somehow automatically? Do we have? No, we don't. Here is maybe some documentation. I think this is what we read. So how to bind the thing? Always the discoverability of this stuff. No, they are ATA3, not SCSI. Okay, this really bound automatically. That is interesting. I think I never used that. And maybe so have you haven't. Interesting. Even I at times learn something new. Which one versus where is it? It's 2. Interesting. Is that really? I mean, it is possible one is an SSD. Interesting. So we learned something new. That's cool. The question is, we probably don't want to have that in the init RD. So core temp, drive temp. But I mean, it doesn't really matter the most, to be honest. What is with, I think that here, which one was that, by the way? Why did this fail? How did, my GNU org still fails? Or did I? Nah, fun stuff. Can we ruin our system by deleting that? I should only, I mean, I tested that in a VM, just I thought in testing it is fine. No, it works. Yeah. Pro tip, don't try experimental patches on your workstation. Oh, that was also wrong. Let's hope. The only thing is, does the stage 0 stuff now link to the wrong read line? Anyway, we have some comments. So, I mean, yeah, it's probably small, it's probably tiny. Welcome everyone. Just wanted to know if plans some work on the PS. So no, I can't read. The YouTube heart button is I can't read the text because the bloody heart button is in front of it. P3, okay. Copy and paste this to. I will continue with the PS3. Of course, not full time. I mean, the more you shall subscribe and Patreon and stuff, the more I can continue. It will probably be every quarter a little bit. So at that time, we might have 3D graphic in a decade. I will also soon train my 3-year-old to hopefully write some basic code soon. So then we are 2, and otherwise patch is welcome. But yeah, I will continue. But so much time, right? Some months ago, I had to hunt the storage regression, which they broke upstream. That took probably a whole day. And like basically, if there would not be like recurring theme, if there would not be so many upstream regressions, I would have more graphic acceleration, right? But I burn, like every quarter, I burn a day on stupid regressions because Linux kernel people break something. So yeah. Which one is that? So pick, what precisely is picky? Some Intel stuff of provides digital reading CPU packages and course accessible processor picky interface. That was 2020. I mean, fair enough, I guess. It's some CPU temperature driver. So yeah, then this looks mostly fine here. VIA, what precisely was that one here? AMD emulated sensor? What is that? Source bridge? What the freaking heck is that even? It would really help, like I said 5 minutes ago, it would really help side band 7. Like, why is there not a freaking standard, right? Why do we even need half a dozen? 1, 2, 3, 4, 5, 6, 7, 8, 9. -2 for drive temp and dim temp. So first implemented family 10 hex, later replaced pinch, which provided direct access to integrated thermal diode. Modern can have larger number of thermal sensors. Emulates a typical remote temperature sensor chip which samples analog signal. So SBTSI was first implemented on processors of the 10 hex by replacing pins which provide implements a subset of the SM bus protocol, system management bus. Sideband interface, processor family model specific details are documented in the BIOS kernel development. Programming sensor, that is super freaking old. Then let's just put the Phenom to sleep. Now I'm curious whether that's probably not loaded, right? Is it loaded on the 750X? It is SBTSI. It says even alias for AMD SBTSI. I2C SBTSI. SBTSI temp. Maybe unused. Probably doesn't do something on the Phenom, does it? Which family is that even? Family, model, stepping. Family 16, that is 10 hex. They said 10 hex, right? 10 hex. Because that is exactly what I was wondering, whether that has a chipset sensor. By the way, then did I mod probe that? SBTSI. Not instantly. Researching live things you didn't even know existed. That was SBTSI sensor driver to Beer 511 is not that long time ago. Google engineers have been working on AMD SBTSI. By the way, I really hate those websites that only list, like maybe we should do the same, get more clickbait and stuff, but like other website just listing other websites thing is like really annoying if you only... I have the impression this is this device tree, AMD stock temperature, compliant. I have the feeling that is some BMC emulated increments of. I have the feeling that is some other special stuff. Anyway, all of those are not that large. Yeah, 100. No, not 100. 12K there plus compression. Yeah, that's probably fine. So let's add that. Long story short, but that is also like doing some research, right? How do you know lots of stuff? Because you're curious, you perfect your local setup, you find some stuff that you never heard about, you Google some random stuff, and yeah. Any wish to learn patch things yourself, just do it, right? Like some things that start with the small things, something that annoys you, it doesn't work, and sooner or later you get to the more complex stuff. So let's add that. Basically, I had that here somewhere, like here. So then that too. We probably, because I don't want to grab that, probably should work like that. We will find out soon, because I don't want to over grab their stuff. Or do we have any? Maybe we could check if we have. No, it's anyway not more. That's probably fine. The benefit of that is that for the installer, so not only for, so that is purely for testing, to be honest. But the benefit was of the other one, I also wanted to add the CPU frequency scaling things. Because currently you don't have CPU frequency scaling when you install it, and it's not the biggest thing of the world, but if you use this for testing, the same ISO, right, you want to test some stuff, system stability and whatnot, you boot and run some stuff, it would be nice to have CPU frequency scaling. So we have ACPI, we have quite some. So unfortunately, they are also here this governors, which we would not necessarily need. What was pstate UT? Test module. Thank you very much. Why do we even have that? UT for unit test or what? No point of building a unit test driver thing, especially to ship it in the init. The best, so speed step, power now, PCC, what was that? Processor, clocking control, interface driver. Doesn't immediately ring a bell. Platform firmware. Sounds like some generic thing. Something. I don't think I've ever seen use of that. So best would probably be, so we want this ACPI thing. What precisely is that thing? Feedback, power save bias for the on-demand governor. Complex stuff I've never seen before. And what is P for clock mod? Is it some other? Pentium 4. Why does it? So the name probably sucks. Maybe that was the initial first attempt of clock modifying thing. Because I read here, the name is a little bit shitty. Like sounds like modding, like over under volting, over under clocking. But it sounds like it's normal. Here's at least here they only write CPU frac driver for power. So the name sucks a little bit in my opinion. Recurring theme here with the Linux kernel community, the best of the industry. Anyway, so basically all of those, I would think. I mean, so what we would want to filter out is this on-demand stuff. And luckily, so we could filter. How do we do that? We could grab CPU frac and then not those, and like poor man's not C, not P, not U. That would work. I mean, we could do it like that. Maybe it's more readable. Another trick would be all the others have, the ones we have dashes. That would be a little bit hack until the Linux kernel developer changed that. Sometimes I like to use such tricks of like not underscore. Why do we need maybe plus? Should this not work? Why does that? Because it doesn't match to the... because this is a this matches the first, so this forces us to match to the end. That probably should do the trick. You probably want to read the freaking manual of regular expressions. Danny writes, yes, just do it. And the OS best learning platform, playing along home with us here at online. Happy to hear that. So yeah, if you were wondering, so this matches, so the reason this still matches is because this only matches one or more, so it matches CPU frag until there, and then that satisfies the match, right? So that is, if we force it here to match until the end of line, then those others do not match anymore. The question is, what is more readable? I mean, this is a little bit more hacky, but it filters out this CPU frag sensitivity by chance. I mean, maybe I run with that one here, to be honest. Just because I want this one more module filtered, so yeah. So, not that end of line, yeah, that's probably fine. So then, that build here did not yet get that much further. We probably should test that. You know what, let's test this in a full build. Bob says, other people say, nice videos. How can other people like me can contribute a guide for complete... You want to contribute? How can other people like me contribute a guide? Just send it in by email, by Discord, by YouTube chat. What we have already some guides. I mean, we will be working after updating everything and the kitchen sinks the last 5 years here on YouTube. We turned a little bit on the website. The website is already a little bit, yes, a little bit. Thanks to our contributing developers, highly appreciated. Here's some documentation, right? You need to be careful not to repeat. Here is basically quick install, quick build. Actually, I probably should check if that is not too outdated. There is this big handbook that also a little bit outdated, but mostly still okay. And here's some magazine stuff, right? So here is already, but yeah, I mean, the science stuff, we can always publish anything. So the thing is with website, it needs like a more overhaul, right? So it's not like you do that in one day and you're completely done with it. So, and it's not the most rewarding, right? If you have technology to work on and pressing tech issues to fix, then it's not the first thing you work on website when all you wanted is an amazing Linux distribution. So build that here in that. Some modules need... This should not really happen. probably, but now who needs CXGB, whatever, anyway. Yeah, whatever. Do we have... It should be somewhere... Do we have search here, do we? Yeah, here we have now SCPI, CPU frequency stuff, and the other was temp. Core temp, drive temp, chipset temp, K8, K10, via Pecky, which whoever uses it. Yeah, it's probably not that much larger. Let's take a look. It's highly compressed anyway, and yeah, 23. Of course, it got a little bit larger again, but we're still, I think yesterday, by pure chance, I removed some duplicated library things. So we're plus minus 0 probably, and more sensitive would be PowerPC. Do I have a, okay, that is still building. The good things maybe as one last thing, yeah, of course, 40 minutes. Define best Linux distribution. Best Linux distribution for me. Did I not change this in the title? But yeah, I mean, obviously you need to do some clickbait, right? My more clickbait. I wrote here best Linux distribution for himself. It's in the title. Best for me. Best working, most minimal, less obtrusive, least bugs, highest performance. Best. Just for me. Just for fun. Just for fun and big business. And so we're building this stuff. Maybe we can last see the E2FS procs thing there. And then, so that probably should be fine. Okay, init RD. Include CPU, frag, and temp. Modules in RDI. You don't see this, but now there you see it. That comes from using professional 16 by 10 displays, like one should do. So then, do I have a PowerPC build? Of course I don't. But so because the thing is, I should have. Do I still have ISOs? I don't have ISOs. Of course, I don't want to rebuild port locking sequences here. Serve org, nothing like doing this straight on your download. Binary 2023, let's loop back mon straight on the web. Server, content distribution network. T2 32 whatever, PowerPC 64. 970 should probably do. And then tar am I in the right direction? That probably should work. So, 6 whatever from the last ISO. Yeah, CPU frag. So power NV, should we not have? That is a little bit so good that we double check that. should we not have a... Or did I accidentally build one into the kernel? Maybe I changed something recently. What was the G... Was it G... Oops, not G6. Maybe we accidentally built... No? Here, PMax 64. Yeah, I think I changed that. When we resurrected a Rack Mac recently, I believe I noticed that, and I believe I changed that. Actually, we believe is one thing, double checking is... Yeah, pro tip, double check stuff. If you believe something, then probably double check something. Otherwise, you realize often, more often than not, you will realize months later. No, this is not changed. So, as a wind farm, maybe as a wind farm, Apple Wind Farm. Oh yeah, I want to change Apple Wind Farm. Oops. So yeah, then some month ago I realized Apple Wind Farm stuff can be modular because then we don't waste memory on the PS3. But then the question is, can this be modular too? And what will be the module name? Do I have a build? Probably not. Do we have here something I can recycle? I don't know. How is our Linux distribution becoming so good? Because each time we find something, we just check it, right, and improve it. It's small things, but it's accumulating, right? The funny thing is, a funny anecdote, I recently tested Intel Clear Linux, and I was shocked that we have a fully modular kernel, meaning only the most core things are in the kernel. Everything that can be a module in T2, I try to make a module, because then it's not loaded into your address space and so on, and you can, even if sometimes I even hack something, right? I want to fix a bug, and then I don't need to reboot. I can, because it's a module, if it's not primary storage and whatnot thing, I can unload it, I can reload it, right? Of course, that's not every user, but for every user, it's like on a PS3, right? If everything is built in the PS3, in the PowerPC kernel, then we waste tens of megabyte for unused drivers in the PS3, right? Or other embedded boards. I was shocked when I saw that the Intel Clear Linux stuff is the exact opposite. Not a fan of that. And then you also have a monstrous kernel, right? 30, 40 megabyte or 50 or whatever. The kernel was humongous, no idea what they were thinking. So drivers, CPU, frac, kconf of PowerPC maybe? PowerPC, that is bool? No, this cannot be. Why is this not? Why is this a bool? Do we need CPU maple? That is a little bit unfortunate. Here's also CBE. That can be module. That is a tree state default M. Why is this shit not a module? Maybe I even checked it then a month ago when I saw the wind farm, and it is possible that it's the second time that I check this stuff. They have here stuff in load show 750 PLL, gets called via PMO, PL selection, 750 FX CPUs, default really. Other place, most of you. Hey! The kernel developers agree this function should really be moved to some other place, as most of the C written via PMO. Thank you very much. Okay, that's unfortunate, but good that we double checked it. I only wonder that should be, yeah, that is PowerPC 32. So we don't, I probably copied that a long time ago, so that doesn't make sense there. Do we have Maple enabled? No, it's anyway not. We don't have PA semi for some reason. Should this not be enabled? By the way, I really would love, for my, oh man, I would so love to have a, has nobody a PA semi? That would be so cool. Not that it would be the most practical these days, but yeah. Anyway, let's double check what we have in the CPU frag. Yeah, we have only the one there. Where do we have P? PowerPCs, PMIC. I wonder if this breaks something, but no time like this year to find out. PASemi, of course, a previously power efficient PowerPC implementer that Apple acquired in 2000 whatever, 4 or 5 or so, and that allegedly became the Apple Silicon ARM unit, with obviously hundreds of new people since then. So at least some stuff. What else did we want to check? We wanted to check the temperature things. How much hard? So yeah. So we have hardware mon temp. It's funny how that is PowerPC. So this does not have any PowerPC things. It's funny that we have this Pecky thing in there. I mean, the one was built in. What would be the others? The others, is it wind farm? Here we have some IBM Power NV. Does this work? Probably not. Or can you mod in for a... Oh, it works. Cool. At least something. If we don't get much, at least we got that. Ah, darn, that doesn't... We grab on... Yeah, that is the thing, but if you limit that, obviously you have some false negatives. That is not, I mean, it's not mission critical, right? It's nice to have. I also wonder, do we have some sun stuff? But knowing the sun stuff, maybe not. Does the sun stuff have... Oh, wait, this is... Yeah, clever. Checking a PowerPC tree for sun stuff. No, that is not sun. This name is also stupid, right? Only all winner can name their stuff sun. Here are some. So what do we... So that should match. I think this US3 was matching my Ultra, my Sunblade 1000. Okay, and temp. Here is some Ultra 45. I don't have What is the name? Ultra 45 env. Yeah, if they would be a little bit more, if they would be grouped in subdirectories, a little bit more consistently named, but like this, nah. Probably this monitors more, including voltages and whatnot, offense. So Ultra Spark we have there. Do we have IBM Power thing here? Here's Power NV sensors. Did we? So we have here Power NV, IBM. Okay, this is IBM Power was the other. This is funny. This is Power NV. The naming is completely inconsistent, right? So one thing I would also do better in microkernel is naming this stuff more consistently. I mean, it's not really worth it, but we could add 2 for illustration purposes only. And then we probably worked 1 hour on our Linux distribution and call it a day. So if we wanted more, then we could hardware mon. I mean, the question is, how many exceptions should we make? I mean, it's only, maybe we don't do that because it's extremely only nice to have. And we only do not some. What was, the name was stupid. What was the name? Okay, it's Spark. It's also Longson. Ah, wait, this is. Oh no, the CPU frequency things should match actually. We only filter out. Actually, I don't need to do anything for that. What more do we have here? Should we include that? Okay, maybe not. Okay, the Musel build otherwise, that was Musel, right? What did we build here? x86 Musel, yeah. Should be Musel. I mean, most people use x86 anyway. For that we have it included then. And theoretically, by the way, pro tip, you could always peel it out of, you could always, like if you wanted all modules in the installer, you can always just untar the Linux kernel package in the T2 running system, right? Then you have all modules. Actually, maybe we should we? Maybe we should include some, is it obvious? I mean, I was wondering whether we should include some help notes there after boot up, like booting and then like, by the way, some, but maybe that's too noisy, maybe common sense applies and stuff. Anyway, that's it for this video then. We made this stuff better and had some fun together. I hope you enjoyed this, learned something. Don't forget to share, like, subscribe, maybe Patreon or GitHub sponsor. Have a good day and night, and I hope to see you soon for all the next fun and making our Linux distribution